In homework 3B, question 1, we're going to look at the determinants of bond demand. In this scenario, we paid $940 a year ago for a 10% $1,000 10-year bond that was issued 3 years ago. Okay, so what we want to put in here is the rate we don't know. The number of periods is 10 years. The payment, the price, or the coupon payment is 10% of $1,000 or $100. The price that we paid a year ago is $904, and the face value is $1,000. The number of periods is kind of odd because the bond was issued 3 years ago, so we missed out on the first 3 payments. There was only 7 left. So I'm going to change this to equal 10 minus 3. There's only 7 payments left. Okay. The demand for this bond is given in the following equation, with price as a dependent variable and quantity as the quantity demanded for the bond. How many bonds are going to be purchased at a given price? So at 904, the quantity demanded for the bond is what? Well, we can copy this equation into Excel, and the price okay, so we have this equation here. We've replaced P, the price, with the price we paid for it. Then we'll copy it down, paste it here, and then we're going to subtract 904 from both sides, and then add 0.55Q to both sides. And then I'll copy and paste this down here. And then what we'll do is we'll divide both sides. We'll divide the left-hand side by the coefficient on Q. Okay, so then Q is equal to this right-hand side, right? 520. Okay. And we get the correct answer. Instead, if the price had been $884, the quantity demanded would have been what instead? Well, I'm going to go and just copy this and put it down here. And then instead of 904, the price is $884. So wherever I see 904, replace it with 884. And you get to 3 decimal places. $556.364 billion. Okay? And now we got to plot this point on the graph. And I got this nice little tool called Page Marker. It's a Google app. I'm going to click on that. I'll move it over here. And then for my first line, or my first point, I'm going to label it blue. And the price was 904. So the prices are right about here, right? Whoops. Okay. 904 is right about here. Right? So I got to dash over to here. And write 904. And I'm going to label this the price. I'm going to label this the quantity. I'm going to label this demand. And then I'm going to go straight down to my quantity of 520. Okay. And then I'll change the color to red. I might shrink up the line size. And at the price of $8.84, which is right about here, and it doesn't have to be exact. Bring down the quantity, and the quantity is I don't know where I'm going to put it. I wrote a little big here. 5, 5, 6. We'll just call it 5, 5, 6. Okay, that's your first graph that you have to turn in. So and then the price was $8.84. So when the price fell, the quantity demanded of bonds increased. We call that a movement along a demand curve. Okay? I'll go ahead and clear that and close my pen out. Okay, now down here, now recall that initially the assumption was that we paid 904, right? What's the current yield? Well, remember what the current yield is from our discussion. The current yield from the classroom discussion can be found by just taking the coupon payment divided by the price. So let's set that over here. Okay. So you have the current yield divided by the price, or the coupon payment divided by the price. So the coupon payment is $100, and the price was 904. We're going to turn that into a percent with 3 decimal places. Copy and paste right here. Get rid of the percent symbol. So far, so good, right? If you expected the price of the bond in a year to decrease by $42, right? Decrease by $42. The expected blank on the bond equals what percent? Okay, to figure this out, we have to find what the new price is. The old price was $904, and we expect the bond to fall by $42. Right? So this is what it is. And the 904 is what it was. Okay? And remember, the gain or loss is the percent change in these two, right? Just format this up a little bit, make it look neat. Oh, let's do this. We'll pull this down. Okay, remember the gain is what it is. We expected it to fall by $42 minus what it was divided by what it was. And so the gain is a negative 4.646%. So we're going to put in loss here. The expected loss capital loss, not a capital gain. And because we call it a loss, we give her the negative sign, and then we don't need the percent symbol. And we hit enter. Okay. What's the expected return on the bond? Well, let's open up let's go to our PowerPoint notes and go to section in the class. Okay, so this is our gain, and because it's negative, we have a capital loss of 4.646%, and then we got to add to that the current yield, which is the coupon payment divided by the price. So I'll put in here the current yield. We already calculated it too. The current yield was the price, the coupon payment divided by the price, and then in percent form, and then 3 decimal places. Then the return, our return is the sum of these two, 6.416%. So we're just adding this to the negative gain, or we're taking the current yield and we're subtracting off the loss. Okay. So if you do expect bond prices decrease by $42, maybe some expert on CNBC or Fox Business Network is telling everybody, hey, bond prices are expected to fall by $42. Then the average investor's demand might fall, as it's shown in the diagram below. The new bond demand is this red equation, and because the demand curve has shifted in, if we hold the price constant, demand has shifted into the red curve. At this constant price, quantity demanded has fallen from here to here. So we call that a decrease. Bond demand will decrease. Okay? Now we got to label this diagram. Let me go ahead and label it. Shrink the pencil down. 904, remember, was right about here. Right, just above the line there. Okay, and we'll write 904 here. And this is price. And this is quantity. And this is demand 0. And this is demand 1. Okay? And then demand shifted inward. Okay? Inward shift. Okay? We need to find the original quantity. What was the original quantity? At 904. The original quantity was 520. Now we need to find the new quantity. So I'll close that. Oh, I cleared it, man. That kind of... I'm new to this tool. Okay, so we need the new quantity at 904. So I'm going to do is I'm going to copy this and just paste it down here. And I'll make it red. Okay, so the price is 904. The demand curve has the same slope, but what's different here? The intercept is 1133. So wherever I see 1190, I'm going to replace it with 1133. Okay, so on the new demand curve at a price of 904, quantity demanded is 416. 416.364 billion bonds. Now, since high expected rate of inflation is associated with a low expected return, bond demand is low when the expected rate of return, or when the expected rate of inflation is high. Since high expected and future interest rates are associated with low expected return, bond demand is low when expected future interest rates are high. So let me just type those in. Hit enter. Okay, so what does all that mean? Well, I put in the return equation here, but what I did is I put in the price you expect to pay or get in the future, the price that you already paid, the price that you already paid, the price you already paid. These are fixed. There's no change in these. They're fixed. They can't change. But if inflation is expected to be higher, then that's going to eat away your future purchasing power. So the real value of this future price is going to go down. And the real value of this future coupon payment you're going to get is going to go down as well. So that causes the return, the expected return, to fall. And that's why your bond demand is going to be low when the expected rate of inflation is high. So I've labeled this red curve here the future demand. See, T is today, and this is in the future, 1 year into the future. And the black line is today's demand. So if you expect the price of the bond to fall in the future, we expect, let me change that color back to red. And erase this. So if we expect the price to fall, right? If we expect the price, the future price to fall, remember, interest rates in the future are going to be, interest rates are negatively correlated with prices. Prices go down, interest rates go up. So this right here is going to result in an increase in the future interest rate. Because interest rates in the future are going to go up when prices in the future go down. So that's why this right here is high expected future interest rates are associated with low expected return. We have a low return and a high interest rate. And that's why bond demand is going to be low. The price, you're not going to want to hold the bond if you expect the price to go down. Okay? All right, so we're going to clear all that. To label this, again, you want to label this, say D plus 1, right? And then 904 is the price that we paid, right? And the new quantity is 416. I'll just leave this 416. This is the quantity axis of bonds. This is the price axis for bonds. I'll change this back to black. And then I can drop this down here. So if the price remains constant, the quantity of bonds we demand falls. And it was like 550 something, right? 520. So when you graph it, you want to graph it like this. And then graph or label out DT for demand today. Change this to red. And then just draw an arrow for lower demand, right? If you can fit it in there, draw an arrow. That's not much of an arrow. Let me try it again. So bond demand decreased. And this is what you want to turn in for your memo. Okay, so let's go ahead and close and then move on to the next problem. Now, if our wealth decreases by $5.8 trillion, bond demand is going to decrease. Bond demand decreases. And we can see that down here. We're going from the red now to the blue. Okay, so bond demand decreases down here. And again, you want to label this graph. We'll go ahead and label it red. Okay, again, this is dt plus 1. This is price. This is quantity. This demand curve down here is dt plus 2 because in 2 years, or in the second period, our wealth decreased by that, right? And then at the price of 904, let me shrink the pin size. At 904, we see that quantity demanded fell, right? Quantity demanded fell. And we got to calculate it. So it was 416 roughly. 416. We want to know what it is now, right? So we want to know what it is now. So what I'm going to do is, this is kind of cool. I'm just going to copy these equations over here. I'll change them to blue. And the only thing that changed was the intercept at 1075. 1075. 1075. 1075. And then down here. Oh. Huh, that's weird. Let me just copy this in here, inside. Okay, there it is. It was just hiding. 1075. And the new quantity is 310,909. Okay, so we can write, let's go ahead and erase the question mark. Erase the question mark here. And then we'll write 311. So if we hold the price of the bond constant, with demand shifting in because of a wealth effect, a negative wealth effect, quantity demanded would fall from 416 roughly to 311. So go ahead and close that out. And then we'll write 310.909. Hit enter. Okay, now we got another scenario. So now this was time period T plus 1, T plus 2, and then T plus 3. So now we've got to change this to green. Now we're talking about demand for time period today plus 3 periods from now. And then blue is what happened a year ago. All right, the previous year. Okay, so if today is 0, this would be 3 years from now, and this would be 2 years from now. And of course, you got to label the p-axis, the q-axis, right? Okay, now in this scenario, all financial commentators on television are reporting that stock markets throughout the world are getting more volatile. So, as stocks get more volatile, it kind of shakes the risk-averse people out of the stock market. And if they're leaving the stock market, they're going to enter the bond market. So this is going to increase. Bond demand is going to increase. Okay? So we're going to eventually write increase in here. Bond demand is going to increase. Right? And this curve, this green equation goes with this green line. So we know that bond demand increased. That's an arrow. Bond demand increased. Okay, from the blue to the green. So I'm going to go back over to Excel. Change this to green. And then notice we're holding the price constant 904, but we're changing the value of the intercept to 1134. So wherever I see 1075, I'm going to replace it with 1134. So quantity rebounded back up to 418. So I'll go ahead and label it so I don't lose. So we're back up to 418. So just to the right of that line, that vertical line. So this is 418 to 0 decimal places, right? And what was it? It was 310.909 on the blue curve. So it was 310. Or 311 if we round to 0 decimal places. Okay? And then the price is 904, right? Okay? So I'll go ahead and clear all this out. And demand's going to increase. Bond demand increases. And it increases. Quantity demanded increases to 418.182 billion bonds. Okay, we're getting close to the end. We only have one more scenario to go. So the now we're in scenario T plus 4, right? So this is demand in time period T plus 4. So if today is 0, this is 4 years from now, right? And last year was time period T plus 3. Okay. So this is 4 years in the future. So 4 years in the future, suppose housing and banking regulations are made much more complex. The liquidity of U.S. homes will what? Okay, so liquidity should be lower because it'll be more difficult to sell the house. And this will increase bond demand, which is shown below. Let me change this back to purple. So bond demand will increase, right? Bond increases from green to purple, right? And if we hold the price constant at 904, then quantity demanded is going to increase if we hold price constant, right? Change that back to green. Put a big dot right there. Come straight down. So this value is 418, right? 418. Label the price axis, quantity axis, and then we want to know what this value is, right? How do I find out what that value is? Well, instead of copying this, I'm just going to copy the last one. Then I'll make that purple. Okay, so 904 is the price we're holding constant. 0.55 is the slope. And then all we have to do is change the intercept, which is on the purple line, 88. 1188. So the new quantity is 516. So let's go ahead and erase the question mark and write 516 right here, right? 516. Okay, so that's how you label these diagrams. And I'll close this out. So this will be, we said the liquidity of U.S. homes should be lower or less, maybe reduced substantially. Does that work? Or less? Okay, so it's less. This will decrease or increase bond demand. And the new quantity at 904 is 516.364 billion bonds. Okay, and that's it for question 1 on homework 3B.